Okay, hello everyone. Good morning in the Europe and good evening to our audience in Indonesia. Before we start today's event, I would like to remind you to mute yourself upon entry to ensure that our speaker will have the most conducive environment for the presentation. Thank you very much. So then let's start today's event. Welcome to today's event, the Open Run Indonesia 5th webinar, which is organized collaboratively by TechBros GmbH, Telkom University, and Telekom Intra Project. My name is Fandi Marcela Marani Yudris, and I will be your moderator for today. Now I will ask you one question to check if you can see and hear us well. Please kindly give us a thumbs up or tell us via chat box if everything is okay, or if you can't hear or see us. All good, thank you. Thank you very much. Okay, let's proceed. Okay, before we go to the main event, I would like to introduce you to our company, TechBros GmbH. So brief and simple, we are a young company launched in 2017. We have our main headquarters in Germany, Düsseldorf, Germany, but we also have our offices in Indonesia, Sweden, and Romania. Currently, we have about 20 plus staffs on board, and we have some key expertise and services, mainly in telecommunication, data science and analytics, AI, IoT, and also talent development. So if you have any inquiries, do contact us via LinkedIn, via our email, or via our website. So, okay. Now I would like to inform you about our agenda for today. We are so lucky because today we are joined by not one, but three extraordinary speakers that will share with us their knowledge and insights. Each speaker will present for about 20 minutes, and after each speaker finish with their presentation, we will have Q&A session for about 10 minutes. So first, we will have Mr. Marcin Triansky, CEO or Principal Consultant in Remedo Lab, will present us the topic ORAN architecture. And then Mr. Martiaz Mazur will join us with the presentation of Open Run automation. He is currently the product strategy manager at Canonical. And last but not least, Mr. Clemens Cibuchka will join us with the presentation about Open Run competence development. And he is currently working in TFK Technology as country manager. So after each presentation, then again, our audience will be given about 10 minutes time to ask questions to our speaker. Do utilize the raise hand function of this Zoom platform. And after your name is called, you may unmute your microphone and turn on your video if you may, and ask your question directly. You can also write your question in the chat box, but we'll be prioritizing the ones raising hands to ensure that the Q&A session for today will be as interactive as possible. And at the end, before we close today's session, we will have a picture session. Okay, now before we jump to the first presentation, I'm so excited. I would like to remind you about the rules for our webinar for today. First, keep your microphone muted during the presentation and use the raise hand function if you have any question during the Q&A session. You can also use the chat box function to ask questions or to join discussion indirectly. Don't forget to be respectful to your fellow attendees and enjoy today's session. So without further ado, let's now dive into the first round. I have a great pleasure here to introducing our wonderful speakers for today who are going to share with you their thoughts. First, we'll be hearing from Mr. Marcin Triansky, CEO or Principal Consultant of Remedo Lab. Mr. Triansky, how are you for today?
I'm fine, thanks. Hi.
Hi. Is it possible to turn up your microphone a little bit? Because from my side, your voice is a little bit quiet.
Okay, how is it now? Is it better?
A lot better.
Okay, thanks.
Yeah, thank you very much. Yeah, if you're ready, the
Yes.
stage is yours.
Thank you. Okay. All right. Okay, so thanks for the introduction and for having me here at this webinar. Welcome everyone. My name is Martin Driański. As it's been said, I'm the CEO and co-founder of Rimedo Labs, a spin-off of the Poznań University of Technology in Poland. We are a research and consulting company focusing on wireless communications, 5G and beyond, and for now on Open RAN, as we are going to speak about this. And my talk today is on ORAN architecture and a little bit of use cases due to the limited time, where I'd like to touch upon some aspects of Open RAN as per ORAN Alliance definition. And a few words about myself. I've been involved in 5G development since 2012, where I've been a work package leader in 5G Now project. Later, I was working as a RAN architecture consultant at Huawei R&D office. And I'm also a co-author of a book entitled From LTE to LTE Advanced Pro and 5G, published by Artech House. And I did my PhD on radio resource management for LTE and 5G. So let's get down to the actual presentation. I'm going to speak a little bit about ORAN itself. It's the 5th webinar, so I believe you are already familiar with the concepts. But to put a little bit of a background here, and then I'm going to speak about the architecture in 2 levels. The first one about the ORAN architecture as defined by the ORAN Alliance, and then going a little bit deeper into the ORAN RIC architecture. And at the end, I'm going to basically sketch the use cases as defined by the ORAN Alliance and focus on one of them. If you are familiar with my latest LinkedIn updates, the traffic steering is the one we are focusing, and I'm going to speak about this one in terms of how ORAN Alliance is dealing with that particular topic. Of course, that could be then interpolated to other topics as well. So to the ORAN introduction. Well, the basic idea is that we go from the traditional RAN where everything is in black box and hidden between in front of the operator, or couldn't be split into the several vendors that could develop the solutions or develop the algorithms in that particular radio resource management area that we are focusing within the ORAN part, and going towards the open architecture, the open radio access network. There are a few things to mention here. First is that we are disaggregating the different functions. We are going to see them exactly in the architectural point. And split the different elements into several boxes. A second is that we have the open interfaces. That is the most important one, I believe, because it allows to open the ecosystem and introduce more players to the game, and also decoupling hardware from software, which is basically inherited from the virtualized RAN, where the functionality is strictly in software that could be put on a pretty much COTS or cost commercial off-the-shelf hardware. important aspect, and this is where we are focusing on in this particular presentation, is the intelligent management, meaning that we have the orange box or run intelligent controller, where it's basically allowing to develop additional functions or algorithms as a separate functionality to the run that is not hidden, that is open for the introduction and allows to have a common platform to manage the radio resources and the whole network. If we are now getting a little bit more closer look to those boxes, so we have the central unit, or OCU. The O here means that it's Open RAN Alliance defined. So OCU split into control plane and user plane. ODU distributed unit, and ORU radio or remote unit. What that means is that between those boxes, there are open interfaces that allow that each of that box is developed by a separate party. They are called E2 nodes in the ORAN Alliance definition, due to being connected to the already mentioned near real-time RAN intelligent controller, or RIC, over E2 interface. We are going to speak about that in detail, so I'm not going to go into the details right now. The important point is that there is a management interface where the external entity or RIC can control those entities in terms of policies or actions that they could invoke. And on top of that, the whole RIC is split into two parts: near real-time and non-real-time over a WAN interface. Basically the name already means or suggests what they are working on. All of that is responsible for management of the radio network. And we also have, we haven't forget about that, the scheduler or real-time management that is incorporated into ODU. That is not, let's say, get outside. So we have, in general, 3 control loops here. The first one, non-real-time, meaning that it's larger than 1 second, and it's more of the orchestration of the whole network. I believe the second speaker will speak about that in more details. Then there is a near real-time, where functions like mobility management, traffic steering, interference management, and so on take place. And this is where actually the radio resource management functions can be implemented on top of that. So this is where we manage the radio resources with a near real-time domain basis. And then the final one is real-time, so the scheduling, radio resource allocation, power control, modulation, coding, scheme selection, and so on. So that's basically how it's split. And in terms of the management, and the scheduler, as you see here, is incorporated into ODU, but it could be controlled with near real-time RIC in terms of policy management. So we could basically say that for this type of users, we have the particular portion of the band allocated without having the possibility to control them per TTI basis or define per user the resource allocation. So that's the basic concept here. And now, who is involved in those developments? Well, first we have 3GPP standards that define the overall architecture and all the functionality related to the system, like for 5G or LTE, or 5G advanced as of now, and then 6G, of course. Then the portion of those functionality is as an input to the ORAN Alliance specifications. So basically, we don't have there all the control or the core network functionality. We take the radio access. And then going further, the ORAN Alliance specifies those interfaces, those additional functions, the split between the different entities, and a functionality related to the actual development of the radio resource management and intelligent management. And then we have several bodies related to defining the exemplar platforms like ONF SDRAN or ORAN Software Community that develop exemplar platforms for to allow having a standardized way, or not a standardized way, but implementing the ORAN Alliance specifications to allow integration of third-party solutions on top of that. And then we have the Telecom Infra project that is there to, with a particular intelligent and automation subgroup, working on developing the use cases that are prioritized by the operators. So basically the way is as follows. So on the left side, we have reference designs, then we have exemplar platforms, and then we have use case development, so that we make sure that we solve the particular problems of particular operators that are related to the actual needs, taking into account the proper design and making sure that different companies who take part in these developments use the standardized platforms for developing their solutions. There are also other entities like Open RAN Policy Coalition to promote those policies. And there might be other entities to show up like cloud platforms for placing ORAN, then interoperability testing, or maybe in the future XApp stores where companies who are only focusing on the XApp developments, so the applications to run on the rig, will be able to provide their solutions, and the operators will be able to test them and select the ones that they need and that has the best performance. We are focusing on ORAN Alliance, so I just want to mention here in a few seconds the working groups, what they are doing. There is the overall work group number 1, focusing on studying use cases and the overall architecture. Then we have 2 working groups working specifically on the RIG, splitting into non-real-time and real-time. Then we have 2 working groups working on open interfaces and specifically on open fronthaul and the other interfaces we already seen. Then 3 working groups working on virtualization, modularization, and the white box reference design. A working group focusing on transport network, and a new working group focusing on operations and management. There is one new working group on also a special focus group, as it's mentioned in the ORAN Alliance specifications regarding security in this new ecosystem. The important part is that the specifications are at different maturity levels. So if you're speaking about front-haul control, user synchronization, they are pretty stable, whereas the new working groups just started to work on some aspects and they are not being specified yet, or they are basically in a technical report basis. So as of now, it's pretty impossible to build end-to-end standardized ORAN compliant system, but we can build it partially, which means that it will have some proprietary components that will require to agree between the parties that would like to join forces to create the overall solution. ORAN Alliance specifies or has its virtual exhibition where the different companies put their solutions in terms of or in a way of presentations or movies showing the different elements of the ecosystem. So if you're not familiar with that, I encourage you to go there and look for specific aspects. And as already mentioned, it also has a software community, which is a collaboration between ORAN Alliance and Linux Foundation to support the creation of RAN software, where all the building blocks we already mentioned are defined as separate projects like central unit, distributed unit, SMO, or RIGs, or even XApps, as well as, of course, the platforms like simulation, project, or integration and testing and infrastructure. So that would be the introduction. Now, getting a little bit closer to the architecture, let's start with the entities that are defined with ORAN. We already mentioned the blue boxes and the rigs, but it's a little bit more to that. There is a cloud computing platform called O-Cloud, where all the different entities need to basically sit in terms of their operation, with supporting software components like VM, monitor OS, and runtimes. Then we have the actual base station elements like the ORU, hosting the lower layer functionality, ODU hosting the pretty much layer 2 protocols, and OCU CP and UP being the split between the control plane and the user plane of the higher layer protocol stack of LTE or 5G base station. The near real-time rig, I already mentioned, is enabling near real-time control and optimization of the RAN elements, and it hosts the X apps, being the application designed to run on near real-time rig microservices, and they could be developed by third party. They are to be independent from the non-real-time near real-time rig. Then we have non-real-time rig that does not have X apps, but they have R apps, not seen on that picture, enabling non-real-time control and optimization from elements, also incorporating AI ML workflow and policy-based guidance. And non-real-time rig is basically part of a bigger entity called SMO, or Service and Management Orchestration, supporting the orchestration of the RAN components. Speaking about the connections between those entities, it looks as follows. We have the A1 interface between non-real-time rig and near real-time rig, where basically the policy enrichment information and ML model management goes from the models and calculations taken a longer time on non-real-time rig to the near real-time rig, and specifically going up, there is a policy feedback saying basically if it works or not, and pretty much how to adjust the policies if something is happening. Then we have the already mentioned E2 interface. I believe the most important one, because it allows to control the processing elements of the base station, the blue ones, with actual actions. So suspend, stop, override, control via policies. And then from the elements back to the near real-time rig, the data collection feedback happens. There is, of course, from the SMO to all the entities, so to near real-time rig, to the OCU, ODU, ORU, the FCAPS protocol, or the FCAP interface, O1, or Open Front Haul M-Plane, where it's focusing on basically the FCAPS functionality, so configuration and configuration discovery, and getting the performance and resource updates. Same happens for the ORU, and we also have O2 interface that is basically doing pretty much the same thing, but for the O-Cloud. So to manage the actual resources and workload management for the underlying computing platform where this functionality sits. Now, what is important here is that that architecture is pretty flexible. So we have several implementation options. Pretty much the one that we had on the previous picture, where each of that element is separate, and we have the E2 interface to each of that element. But we might have an aggregated E2 node where it's composed of several entities from those. Then we have one E2 interface to all of those. And then we have the possibility even to incorporate near real-time rig into a single box, meaning that it's internal to the OCU, and it's then focused on the specific OCU deployment. And we could even have a situation where the whole base station is merged as the 4G base station, where the near real-time rig is also incorporated into whole base station, where OCU, CP, ODU, ORU are combined together in a single box sitting on the O cloud. And then the only interfaces connected to that are A1 and O2. That are, of course, only several possible combinations as defined by the ORAN Alliance. But the important point here is that if we have such a construct that is very flexible, then the price to pay for that is that the A1 and E2 interface need to be pretty flexible in terms of, and need to have the possibility to address different types of E2 nodes to address the specific parameters and connections. So that would be regarding the overall architecture. Now getting a little bit closer to the ORAN rig, then zooming in, I believe we have some few more minutes to discuss those. Then we have the following structure, where the read-write of RAN or UE information is stored in the shared data layer and through the database. Then we need to have the subscription management for the different XApps, and that allows the new XApps being developed and put into the near real-time rig for the operation, that we know which of them need specific part of information. Of course, we need the messaging infrastructure, so that or message bus that allows the interaction between those different XApps to get the data and provide the actions they want to invoke. And then we have a specific important function responsible for resolving potential overlapping or conflicting requests from multiple XApps. So basically, if two XApps work on the same parameter or work on the same the type of user, there need to be someone who decides which action is to be taken, instead of avoiding ping pong effects and things like that. Then we have FCAPs for the XApps, too many abbreviations, I believe, here, and lifecycle management of the XApps. And finally, we have security scheme for the XApps to make sure they are operating properly. Now, in this, we also have several implementation options, like a centralized way, where the near real-time rig is serving the whole base station or several base stations, and it has an overall overview of all the parameters, and then can focus on serving particular cells, or a distributed near real-time rig, where each of the E2 node is a separate entity, like OCU, CP, UP, DU, and so forth. What that means is that each of this near real-time rig is focusing on specific aspects. Like for ODU, it's focusing on scheduler, whereas for OCU CP, for example, it's focusing on connection management, traffic steering, and so on. So we have also the possibility here to have a flexibility in terms of how the different companies could design those rigs to support specific use cases. And now on those use cases, a few words about them. The ORAN Alliance specify them in phases based on the requirements and on the priorities from the operators. On the left side, we have phase one, the ones that are elaborated a little bit more, where we have the general things like traffic steering, quality of experience optimization, massive MIMO optimization of quality of service-based resource optimization. I would say that that part is focusing on the overall 5G as such, because independently of what use case do we have, we need to have those on place. We need to have to manage the quality of service, of experience. Traffic steering works in all pretty much cases. Whereas for phase two, we have very important aspects, but also RAN sharing is very important from the operator's perspective. While the other ones, like context-based management for V2X or unmanned aerial vehicles, so for drones, they are specific use cases for specific verticals that might be developed a little bit later, depending on the needs. Now, a little bit of how this is seen in terms of how we handle those within that architecture and where are the particular responsibilities, how that work. I'd like to focus a little bit on the traffic steering, and that's the last part of my talk, where there is a need to address this use case from the operator's perspective. That is, of course, one use case, but it shows what's the point of defining that within the ORAN architecture and how the different entities work together. So traffic steering basically is a way of deciding which function or which user is connected to which base station or base stations or cell or cells, and how to handle the different traffic types within the network. So the challenge and why it's even treated is because it's the previous or traditional traffic steering mechanisms focusing or treat all the users in the same way on average values and adjust the cell reselection handover parameters. Whereas from the other side, from the operator's perspective, it's important to customize the user-centric strategies and allow different to specify different policies or different objectives per UE basis or per traffic type basis or per slice basis. So it allows operators to flexibly configure optimization policies. Now, what's taken here are the different types of data, like measurement reports, the typical ones, but also connection mobility statistics and cell load stats, meaning that we take into account the cell level parameters and statistics, but also per UE or specific UE performance statistics. So we take into account the different types of data, mix them together, and allow machine learning algorithms to define specific policies. Now, of course, we take the non-real-time rig and near real-time rig to control those strategies through the learning mechanisms. And then the final point or the final thing is the actual use case example scenario, where we have the two base stations and a user of consideration being the UE1, where the different types of cells might be defined for different types of services. So the small cell is pretty much, it might be on high bands with wider bandwidth for MBB, and the wide area cells are focusing for control plane and voice calls, so that we don't have and don't need that much of capacity, but we rather need wider coverage, not to make too often handovers. And that UE, for example, has two different types of connections. Of course, it needs to have the control connection, but it has voice and MBB connection that have different requirements. And then non-real-time rig takes that into account. So from one side, it gets all the information from the measurement point of view. And on the other hand, it gets all the information from the service point of view. And it decides in that particular example that voice and CP connections should be handled on low band. So cell A or cell B is important here. Whereas for the MBB connection, to allow as soon as possible to get all the data to the user and have wideband to support its service, it's better to move that out from the cell A that has limited capacity to cell C or D that has very high capacity. So those policies go down to near real-time rig, where it needs to find that particular user and it needs to convey that information to the user to set up the particular connection that is decided by the policies on top. Now, then what happens in between? The two policies are provided by Layer 1. The first one is that it steers the voice to cell B. And the second one is that it steers the MBB service to be served by cell C or D, of course, if the measurements allow that. What are those policies? Pretty much they are very, I would say, obvious and very easy to be recognized by the human operator. It's defined in JSON files. We have the specific UE ID, one in that case, quality of service ID, so we know for what type of connection do we have them. And then the statements that say that the preference is shall or prefer or avoid or forbid for specific cells. Same goes for the MBB, where for quality of service ID 9, so for MBB, it has specific parameters that say that for cell A and B shall be avoided because we basically want to offload the traffic, the high traffic from that cell to an empty small cells. And then finally, non-real-time and near real-time rig needs to locate the UE and enforce that policy. So what happens at the end is that there is a control message for that particular UE saying to E2 node, in that case CUCP, to perform handover to cell B, and then add cell A for voice and add the small cell for MBB service. So that's the end picture. So what happens, again, to summarize, what happens is that we have specific requirements and specific measurements that are taken by the near real-time rig that basically calculates different policies, the best setup, provides them in terms of policies to near real-time rig for a specific user, and that near real-time rig performs control actions so that the end situation is as optimal as possible. So that would be it regarding the use case. And now to summarize the whole thing is that using ORAN approach allows adding intelligence to the network with external entities. So we have rig, and then we have the possibility to add X apps on top of that, which then allows to control the RAN behavior by declarative policies, which are very readable, I would say, by the human operator, and allows to combine various applications to realize specific objectives, allow hierarchical modular approach because we have non-real-time, near real-time, and then we have the scheduler and actual operation. Then we have the flexible and modular radio access network where we have those different entities and then management on top of that. And it allows to define the RRM applications being XApps per use case basis, because that particular traffic steering application was working for MBB and for, I don't know, macro cell scenario or things like that. But we could also imagine that there is another XApp focusing on a different scenario. And with that, I would like to thank you for attention. And if there are any questions, please move forward.
Thank you very much for the presentation, Mr. Tiansky. I've noticed that some people have already pushed forward their question in the chat box, and that Mr. Mazur, our second speaker for today, has very kindly answered some of the questions and joined the discussions. Okay, and then we'll open the first Q&A session for today for Mr. Tiansky. So if anyone has any question, please raise your hand and then I'll call your name and then you can ask the question directly, if you please. So apparently, we have yet any volunteer. So
Yeah.
Oh, okay.
Hi, this is
Mr. Gaurang.
Hi, this is Gaurang, and I do have a question.
Yes.
Yes,
Yeah.
please.
So Hi, Marcin. Actually, I need to know
Hi.
that as you were discussing about use cases
Mhm.
regarding to pertaining to RIC, is there any use case pertaining to RIC for sleeping cells as well that can be automated based upon machine learning?
Uh, could you repeat the actual use case? Sleeping cell, right?
Sleeping cells, detection of sleeping cells and automating based upon machine learning.
I have not seen that one as a separate use case, but energy saving management and cell outage compensation and those things that you mentioned are, of course, part of the whole thing in terms of the self-organizing networks functionality.
Okay, okay, okay. Thank you.
I would recommend you to go to Oran Alliance website, and the latest news, I believe, shows or links to the priorities defined by the operators to define the use case prioritization with a very granular definition from the actual operators. And there is a big Excel file where all the different use cases are defined with the priorities. So you can find this there.
Okay, thank you. Thank you so much, Marcin. Thank you.
Hi, Marcin. This side Sakhawat.
Hello.
Hi, hello. My question is this: how can we build a more competent in this open RAN?
More competence.
We can improve our competence level in open RAN. What are
You
the
mean
sources?
as a company, or you mean as an individual?
As an individual, I am also working in a multinational company in a telecom. Ericsson, I am working in Ericsson for 5G
Sure.
network. So I want to keep learning more on open RAN. So how can I improve?
Yep. So as of now, I would recommend you to actually read the specifications from the Oran Alliance and start from the overall one. Go a little bit to the details depending on where you are focusing. I believe the overall architecture definition, use cases will guide you to specific places where you need to focus. They are updated, I would say, every half a year. Then there are other options, like if you go to the Oran software community, then there is a source code for the whole base station, for the rigs being developed as we speak, and then you could actually download that and run on your virtual machine or even on your computer and try to develop your own applications or own part of the system. So I would start with that, and as of now, I have not seen many research papers on that, but this is starting to pop up as well. And if I would to give you some more resources on that, that's definitely the Oran Alliance specifications. That's ONF, that's Telecom Infra Project to look at. Yeah, and then of course, when we are speaking about the specific domain, then you need to look for, I would say, the specific algorithms. What I think here will happen is that having that open ecosystem, and when everything merges together, because as of now there are several different maybe not standardization, but the ecosystem bodies like TIP and like Oran Alliance, and 3GPP is also starting to look at this one. I think that this will then allow a more research joining the actual developments, because then we will be closer. There will be companies working on specific applications. But to start with, I would definitely go to Oran Alliance specifications.
Okay. Thank you. Thank you so much.
Yes, I'm Govind. Yes. So I have a question regarding the troubleshooting. Like in ORAN, we will be having the different vendors' white boxes. So is there any troubleshooting framework been developed by this ORAN Alliance, or I mean, in any different entity, that how the troubleshooting will going to take place. In case
Yes, if you allow me, I'm not sure about the progress on that, but if you have a look at the Oran Alliance work group or even the on this one, and then there is an integration and testing. If you go there, I believe you can find something in that part. And also I think in the white box hardware reference design, so work group number 7. If I could just open that so that you already know what I'm speaking about. And if you go to specific, here you have firstly the testing and integration part. You could look there. Software, of course, in terms of specifications, then you could download pretty much all the different I don't know, requirements or specifications related to those aspects if they are there. I'm not aware about any specific standardization specification regarding that, but for example, you have here workgroup number 8, where is stack interoperability test specification. You could look into this.
Okay, thanks a lot.
Yeah, thank you very much. I think that's it for today's first Q&A session. I would like to thank you again, Mr. Diansky, for the terrific presentation and the knowledge sharing. Thank you very much.
Thank you.
Okay, then let's move forward to the second presentation for today. I would like to welcome you, Mr. Margiet Mazur, Product Strategy Manager from Canonical, that will present today the topic of Open RAN automation. So, Mr. Mazur, how are you for today?
Yeah, I'm good, thank you. And I'm really happy to be invited here and to share some views that we have about Open RAN and the general ecosystem and automation things.
Excellent, thank you very much. So if you're ready, you may present them.
Okay, perfect. So first of all, I wanted to thank Marcin. This was a really great presentation and allows me to save some time in the beginning in explaining all the details because he did perfectly. And yeah, my name is Maciej Mazur. I'm currently working in Canonical. You may know us as well from software that we produce, like Ubuntu operating system, Kubernetes, OpenStack, and so on. And earlier I was working in companies like Nokia and HP, building network elements and different network functions. So that's where I come from. And why we are even interested, right? You may ask, like, why infrastructure companies are looking into telecom space. So basically, we see that private mobile networks, and most of them are built on open source technologies, are changing many industries. And we see a huge interest from our customers, which you would not think that are typical, not only telecoms, like mobile network operators and such, but also companies from retail, from industry, robotics, and so on, are interested in building their own private networks, and Open RAN helps here a lot. So if you ask who is already using private mobile network, is it just a technology that is in research papers and in documentation, or is it actually deployed? So if you look at European examples, but there are many in other places of the world as well, like Charles de Gaulle Airport is using this kind of networks. Daimler factories building Mercedes cars, and Bosch and Osram. It was really funny because when in Germany there was a spectrum auction, the first people who started bidding was Osram, a company manufacturing light bulbs. So not T-Mobile, not Vodafone, but actually manufacturing companies were also interested about having their own spectrum and building their own network. So this is like an area of big opportunity, I think. And several of the use cases where I was working on, The first one, it's a little bit funny because the question behind it is like, can you make 5G to grow potatoes in the shape of a box? And actually, you can use it for that. And manufacturing of French fries is a fully automated process. So you get many different machines, and basically you put French potatoes in the beginning of the process, and you get nice packed French fries in the end. So you may ask, what about the box shape? So basically, if you make French fries, the perfect shape of a potato would be ideal, like box shape, because then you can cut it and you don't lose any of the vegetable. And actually, what the biggest manufacturers in Poland, or like growers of potatoes and agriculture farms, are doing is building their own private 5G network based on open technologies, and using it to control drones for spraying the crops and gathering data from different sensors like temperature, humidity, barometric pressure, and then prepare spraying composition which makes the vegetables grow in the desired way, and also size and so on. And actually, this kind of approach improved their outputs by around 15%. So this is like a huge ROI, and thanks to the open technologies, it can be built quickly and easily. Another use case that I was doing was one of the ports in Europe, where we used the 5G network and millimeter wave for tracking of containers and also managing the whole movement of cranes and moving the containers. The benefit of millimeter wave is really great location accuracy. So if you build a setup with a network like that, you can actually use the telecom capabilities in LMF, location, like function for managing locations, and get enough information to actually do like a digital twin of the whole port. So you get like a virtual representation of everything that is there and manage it this way. So I wanted to give you this kind of use cases in the beginning as like a little bit of a carrot of what you can do. And let's now jump into the way how to do it. So open source technologies, as you know, we are promoting open source as much as possible, and different technologies. So the ones that help you to build a mobile private network, first of all, is the Open RAN project. I will not describe it in any more details because it will, you already had that in the previous session. But basically, this is the most popular way of building private mobile networks right now. And this is also the one that I would recommend. What you need in order to have a network, besides the radio part, you obviously need the core part, and there are different open source projects addressing it. The one that I like the most is Magma Core. So basically, this is EPC, but not built in a standard telco way, but built initially by Facebook engineers and now maintained by the community. Following more IT traditional approach. And this is really nice to build private mobile network setups which don't need to be connected to like other mobile operators. So I wouldn't advise to build your next Verizon using that technology, but this is great for IoT industrial setups and so on. So definitely something to look at. Next very important project in that space is ETSI-OSM. I'm actually also part of the community, being the VNF onboarding task force chair. And what OSM is focused on is making the onboarding of different network functions easy. And also there are efforts in the community to make it the non-real-time rig of the Open RAN scenario, which Marcin described previously. So that's really nice seeing different open source projects collaborating together and getting closer to each other. Next way of building your core network is using OMEC. That's also a very interesting one because its goal is to be as much as possible standard compliant. So if you would actually try to build a fully fledged mobile operator based on open source technologies, this would be the way to go, because you get, in addition to the technical bits and pieces needed, you get additional things like billing, charging, and so on, which is important in this kind of operator-like use cases. There is also OAI, which looks at the holistic view. So they focus on the both core network and radio network. And they basically mostly look at the integration of different components together. So that's another interesting initiative to look at. And SRS Run, which is great for small experimentation if you want to build your own setup at your desk with like a simple board like Lime SDR and connect it to Raspberry Pi and have your mini network for, you know, turning on and off your lamp and do some fun around that. You can use that one, and this is a great way also to learn the technologies behind it, what are the components and how everything is connected and interworking. So let me give you now an example small setup that I'm using for POCs and demos. So in order to make one, you need some user equipment like 5G enabled phone or LTE phone or a drone or any other device, right? You need a radio part. You need an EPC. You probably like to connect it to a public or a private cloud to host your applications on. And you need some capacity at the edge also to do computation, because if you want to, I don't know, do AI/ML with graphical acceleration and so on, that's useful. And the setup that I like the most would be using one of the Open Run vendors here on the radio part, using Magma, because it's like the easiest to deploy EPC currently, and connect it to Azure AKS for hosting the application. And on the edge is the compute running the microcloud, which I will dig into later, but basically it's a nice way to deploy the edge compute and also maintain and manage it. So if you are looking at different choices of the implementations of Open Run, you can go with the getting a fully fledged end-to-end from a company like Mavenir, Altiostar, East Wireless. There are many vendors popping in that space. So that's one way. The other is that you take the platform only, and there are two interesting platforms to build your solution on top of. One is Intel FlexRun. So that one was first in terms of popularity, and it works as well on top of Ubuntu. So you can build up Open Run solution on top of that one. And the other one, also very interesting, is NVIDIA's NVIDIA Aerial, and the whole set of products that they have after buying Mellanox and adding SmartNICs into the picture. So basically, if you have any kind of AI/ML use case and you want it to be running at the edge and have 5G enabled way, this would be something that I would advise you to look at. My own experimentation, if you are looking like what kind of hardware do I need to run this kind of POC, the small and easy setup, which will not cost you tons of money, would be to take a Blade RF, which is a board allowing you to work in quite wide variety of spectrum. Obviously, if you are doing any work related to sending signals, you need to check your local country laws. In most of the countries in Europe, there are pieces of band which are booked for like startups, innovators, and so on, and you can freely use them. They are unlicensed, and that's what I would look for, depending on where you are located. And obviously, like, don't break the law if it's not allowed. The second thing that you need is some compute capacity. Like Intel NUCs are nice. There are different configurations, but that's quite easy. And it also, when it's Intel, it allows you to run the FlexRun platform and things using that one. And for the end device, I like to use things like Raspberry Pi or Jetson and the Wayshare board, which has basically a Snapdragon X55 and can enable you both LTE and 5G for your experimentation. On the public cloud front, if I'm connecting it, the Azure Edge Zones are something that I would recommend to try out. With that setup, at least that's the one that I've tested. You can do the same on Amazon and Google, and they are also probably on the same level. But this is, as I said, the one that I'm using mostly and tested, so I can recommend it. Now let's go to the meat of the presentation. So if you have your setup and so on, and you see already from Marcin's presentation that Open Run basically allows you to do all the things necessary to run your network, and it's better. So why it's not widely used, right? So if you look at the technology that was available 10 years ago, you can laugh at it how the mobile phones look like or how the cars look like. comparing it to the technology of today, like latest iPhone with augmented reality or latest the same make and model of a car, there's a huge difference in 10 years, right? So why so many network elements from 10 years ago are available in the network? So there are also networks which are still having network elements running on like ATCA platforms, which is even before the things that we consider legacy today. So why it's happening? Because distributed systems are complex and it's not easy to make a network-wide upgrade, right? So you cannot just take one component and say, okay, now I want to use the latest and greatest tech and upgrade it and hoping that like 10 versions ahead and hoping that it will not break any compatibility and so on. And software operations in this kind of scenarios are even more complex because besides upgrading to a completely newer piece of software, you need to also maintain it, make sure that you patch security fixes and basically do all the operations required to efficiently run a network. So the solution for this problem is what's called operators. And that's something that we propose is the best tool for the job. So how it works, we are already doing packages of our software, like we take a software and you put it into a Debian deb package. You can put it into like a Docker container into a snap. So why not package the operations software as well? So the model-driven operations is an evolution. It's like fourth step of the evolution itself. There are tools for standard configuration management that you know from your OSS systems or from IT in forms of tools like Terraform, Ansible, Chef, Puppet, and so on. It was improved for the level of declarative deployment with Helm and Helm charts, and they are really good in addressing the deployment scenario. So obviously, if you want to start adding more actions, your Helm chart, which is basically a YAML file, is growing and growing, and then you end up with 10,000 lines of YAML, which no one understands, and it's really hard to manage and maintain. So what happened in the Kubernetes space is that we went for the operators for imperative lifecycle management, where we define the whole solution, how it should be working. And the next step of the evolution is model-driven operations, which are implemented in an open source project called Juju. So let me explain how it works. Operators are normal software packages. They are written in Python. And this is like a code which defines the actions, not only for the deployment, but also day one and day two operations. So you need to renew the certificates, you need to do some additional integration, or you need to upgrade an element. It's also addressed by these software packages. And they are exactly the same across many different companies for the typical IT tools. So if you take like SQL database or Kafka, which are used in telco, they are also used in any other domains. So thanks to the open source nature of the project, you get much more people collaborating with you on the deployment of it. So how operators are working? Let's imagine that I have an operator which can do some things, like it defines that it's using SQL database, it defines that it sends logs to syslog, and it's consuming LDAP because it needs it for its operations. So you can have another operator which basically says, I'm offering LDAP and you can consume it. So what you do next, you just write a command called Juju relate application A to application B, and the LDAP relation will be configured between them. And it means that if there is a necessity to exchange certificates, it will be done. If there is some network configuration, it will be configured. You need to open ports, they will be opened. And any other things that are necessary to enable this integration will be automatically done, populated for you. And obviously, you can build much more complex integrations than just one-to-one. There can be one-to-many, and that's usually how it's built. And this is also the way how open-sourced Chunk Kubernetes and Chunk OpenStack, which are very complex projects, are already being deployed successfully in a very, very big data centers or multi-data center scenarios. So imagine that you have an open source project. It can be like RUDUCU from OpenRun, or it can be Magma. You want to do some monitoring of it. So nice open source tools to do that would be Grafana and Prometheus. okay, so let me implement it, right? No, you don't need to. You can just do Juju deploy Grafana, Juju deploy Prometheus, and all these open source projects will be deployed and relate them to enable the functionality. You can do the same with databases, with syslogging, and many, many more. So the ecosystem of Charms is growing every day, and you can go to charmhat.io to take a look how this is working. And what's the nicest thing about it is that it's aware of the underlying infrastructure. So regardless of the substrate where you deploy, is it like AWS, Azure, GCP, or your Kubernetes cluster on-prem, or your bare metal hardware with MAS, you use the same code and the same operator to deploy it. So there is no difference between doing Juju deploy Grafana on AWS and Juju deploy Grafana on K8s. Juju will take the complexity of it and make sure that it's deployed correctly for you. I mentioned MAS, so I want to explain what it is. MAS is a metal as a service. It's basically making your bare metal working like your cloud instance. So you get a real-time API to manage your physical servers and all the operations. So what MAS is doing, it allows you to automate the hardware instantiation. So if you take a new bare metal blade and basically turn on the power, everything will be connected. Yes. Sorry, can you repeat? Okay, so let's leave the questions till the end, and I'll continue right now. What MAS is working on, it's an open source project. It's not exclusive to anyone. So basically, besides Ubuntu, you can deploy other operating systems as well. And you can deploy it on a huge breadth of hardware like HP, Lenovo, Dell, and so on, and also some hardware coming out of Open Compute project as well. So what it gives you is the general hardware inventory, your network configuration inventory, and storage configuration. However, it's aware of all the EPA features. If you need like an FPGA or you need a GPU to be enabled and so on, you can also enable it on the higher layers. And now we jump into the microcloud, which is used for most of the Open RAN deployments that we are connected to. So microcloud, as we call it, is an environment where you can deploy different types of workloads, and it's composable. So not all of those pieces have to be used, and most of them are optional. So what we consider a microcloud is like the smallest sensible way where there are at least 3 blades or like compute nodes. Because like 1 is just a computer and 2 is just a backup or redundancy. And if you want to call it a cloud, it should be at least 3. And with MAS, you get your whole bare metal automation and the provisioning and also reconfiguration of the site, which is very important if you, for example, now have most of your use cases for Open RAN focused on IoT, but in a year or 2, you will get more AR and VR use cases, and you will need a GPU acceleration and maybe a completely different setup on top. You can just call an API and reconfigure the whole site completely, which is beneficial in terms of automating things. On top of MAS, there is a layer of LXD, which is basically giving you machine containers with the same similar technology that was used to create Docker, as well as gives you VMs. So you can instantiate a VM, which is important because some of the functions are not yet CNFs, the cloud native network functions, but they are VNFs working in a VM and not yet migrated. So you need some capability on the side to be able to run VMs as well. Another open source project that you can use is Ceph, which gives you software-defined storage, just like S3 on Amazon and so on. And on top of that, you run Kubernetes, which will probably run most of your workloads. And the one that we recommend is going with microcase because you can easily deploy it and there is not much configuration involved. And it also has a very small footprint in terms of resources used. So thanks to that setup, you can actually deploy many environments like that and manage them in the same fashion, and also use Juju to deploy software and applications on all of them. What you might ask is like, are there any interesting use cases that I can try out now, or I need like a really expensive application for self-driving cars or something like that? Not really. The one that I would recommend is taking an open source project called Unbox, and this is really making a nice wow effect. Unbox is basically, as the name would suggest, Android in a box. So it, on the LXD cluster that I mentioned previously, it instantiates a machine, which is basically running Android operating system, similar that you have on your phones, right? And it can run on a powerful hardware, be accelerated by the GPU, and your phone, thanks to the low latency of a 5G network, becomes just like a viewing device. So you see the screen mirror from that Android running on Unbox Cloud, and you can do gestures and move things around. So basically, that's how it looks like. And besides the real-time input and output streaming, the main benefits of it is the security, because there is no data on the phone. If you lose it, it gets stolen. No one gets access to anything, because if you don't log, like, there is no data on the phone, right? It's just a app to stream video and stream your gestures up to the website. Another benefit is that you can use a really old phone and have still like a great performance. Like the stuff that is running at the edge can be the latest and greatest 3000 series GPU from NVIDIA, and you can play a latest game without no visible lag as well on the phone. So it will basically allow us not to exchange our phones every year and become a little bit more green and light on our planet's resources. So basically that's it. That's what I wanted to say. I'm happy to answer any questions, and I'll be also at the Mobile World Congress. If any one of you is going, I'm happy to meet there in Barcelona face-to-face or virtually. You can drop me an email or ping me on social media if you have any questions that you don't want to ask in public. And now let's jump into the Q&A session.
Thank you very much, Mr. Mas, for the presentation. Now we will open the second session for the Q&A. So is there any one who would like to address their question directly? Please do raise your hand. Or just unmute yourself, maybe. Hello, Mr. Satrio Dermanto, you have unmute yourself. Do you have any question? Apparently not.
Sorry. Yes.
Yes. Yes,
Yeah.
please.
I have one question for speaker that the use case is very interesting to me. However, is there any possibility for the system or foreign system to collaborate with the broadcasting network, especially for the DVB-T2, that they have the PLP, and maybe you have experience to collaborate between ORAN and the DVB-T2. Thank you.
Okay, thank you for the question. Actually, I'm not an expert in broadcasting technologies, and I have no idea if it's possible, but I will be happy to explore that with you. So if you want, just reach out to me on any of the channels mentioned, and if you explain your use case in more details, I will take a look to it. But I've never worked in the video streaming areas and integration with ORAN.
Okay, Miklaj, thank you very much.
Yeah, thank you very much for the question, Mr. Darmanto. Is there any other question? So apparently not. And I think there's also no open question in the chat box. Oh, someone asked for your contact email again. Mr. Mazur, if you may show again your last slide, maybe. Or also in the chat
I
box.
typed it on the chat, yeah.
Yeah, thank you very much.
It's easier to copy and paste from there.
Yes. Yeah, maybe our audience today would like to ask you directly and not openly in the webinar session, because maybe they have their own use cases. Yeah, if there's no other open question, I would like to thank you again, Mr. Messer, for the excellent presentation. Thank you for joining us today.
Thank you very much for having me.
You're welcome. And we'll proceed to the third presentation for today. So I would like then to welcome our third speaker for today, Mr. Clemens Cibuchka, CEO or principal. Oh, I'm very sorry for the mistake here in the slides. Mr. Clemens Cibuchka is currently a country manager of TFK Technology, and today would like also present us a very interesting topic: Open Run competence and development. So hello again, Mr. Cibuchka. How are you today?
Hello, thanks a lot. I'm doing very fine. Hello, and good morning to the entire audience. Of course, also good afternoon for those in the later time zones or in the more Eastern time zones. Thanks for having me.
Yeah, thank you very much for joining us. If you're ready for your presentation, then the stage is yours. Thank you very much.
Let me quickly share my screen. So the screen sharing should be working, I hope. Yeah, so once again, welcome everybody, and thanks for having me on this webinar. My name is Clemens Cibuchka. I am country manager of TFK Technologies Poland. Before we get into the topic of competence development for Open Run, I would like to quickly introduce myself a little more in depth. If you get in touch with me after the session, simply call me Clemens. I would like to welcome also several of my colleagues and customers. I've seen that some of them have tuned in for the session. Talking about myself, I'm a trainer for about 17 years now, mostly for radio technology. So I started on 2G radio technology, 3G, 4G, 5G. And with the development of Open Run and with Open Run emerging on the training market as well, we have started as a company to, let's say, develop different concepts as how we want to bring Open Run to our customers, how we want to bring Open Run training to the customers. And we have figured out that this is something that is very, let's call it challenging, because of the changes that we find together with Open Run deployment. So to give you a quick outline about over the content of my session here. So what's in it? We're gonna discuss first of all the point of, do I really need competence development? I get a lot of feedback from, let's say, former students of mine, colleagues of mine who are asking, you know, I know LTE networks, I know 5G networks. Do I really need to develop for Open Run? And we're going to touch on this topic a little bit. Further on, we're going to have a look at the comparison classical run versus and Open Run. I will not go too much in depth here because, as mentioned, this is not the first webinar about Open Run. And the previous speakers, in particular, Marcin has done a very good job in outlining the different interfaces and so on, so we don't have to repeat that. Still, we're going to have a quick comparison, and also while we have this comparison, we're going to take a look at what different competences are required to be able to work on classical run and to be able to work on Open Run. Then we will touch on classical training. So how does... Yes. Hello? Okay. Then we will have, we'll touch on classical training. So we will discuss how the, let's say, general training approach is today and how this translates into Open Run, and then what else is required. So I'm tackling this subject mostly from the aspect of, let's say, existing network operator, but also maybe existing, let's say, a classical trainer, a classical student who has experience in the classical radio access network. However, a lot of the points that I'm bringing up in this session will be interested also for new players on the market, will be interesting for companies and for engineers who have, let's say, not so much experience on the classical run deployment and in working in the classical run environment. Then we're gonna tackle competence development tracks. Of course, I'm not presenting any, let's say, ready tracks. If I want to be an integrator, I have to do that. If I have to be an engineer, if I want to be an optimizer, I have to do that. When we talk about competence development track, we talk more about the general idea of competence development and, let's say, the different aspects as to how we can get our competences. And last but not least, we'll talk about the few, let's say, key takeaways of the session and some open questions that I want to put out there, which we have found, let's say, challenging to answer at this point, and something to consider for the future, something that I guess is going to be considered also within the Open Run community. I guess it's considered within the Telecom Infra project, but overall, let's say we do have open questions as a training supplier, as a training company, which on the midterm will have to be answered, in particular to be able to provide proper training, either as a third-party training supplier, but also, for example, as a network vendor to the respective operators in the end. Okay, so do I need to develop any competences? While talking to my colleagues, while talking to former students of mine, one of the main things that I get to hear is, look, I've been working in this business for 15 years. I've seen almost any hardware you can imagine from any vendor that is currently an incumbent vendor. I've deployed 20 different networks. I feel pretty much ready for what's next to come. Is it really different? Is Open Run different to what we have right now? And do I need additional competences? And the answer is very simple. Yes, it is. It is very different. There's multiple challenges that are coming towards the existing radio network engineer. In particular, if we take a look at some of the aspects that are coming with Open Run, so such as the changes in the architecture that we have. Marcin has touched on some of those changes in the architecture, made by the implementation of the RIC, which is not defined in any, let's say, classical 4G or 5G courses. The hardware and software disaggregation, even if Open Run does not necessarily imply virtual run, vRun, we're going to see that basically any existing, any incumbent vendor, but also any emerging software and hardware vendor is placing their bets on a disaggregated hardware and software solution, which means this is something that will come towards our radio engineers and is something that has to be addressed as competence development. Together with this, of course, the virtual deployment. So the deployment of VNFs, the deployment of CNFs, network orchestration and so on. These are things that normally they come from the IT world and they're pretty new to the, let's say, radio engineering world. If you take a look at core networks, it's been several years. I'm not 100% sure. Let's say in the past 10 years, we have seen that virtualization was emerging in core networks, and you can see how the typical core network engineer, especially in the beginning, was struggling with the virtual environment, learning the new terms, learning this, let's say, more extensive IT world in comparison to the classical core network commands and the classical hardware they were using. Further on, we have additional interfaces which have to be addressed. So interfaces between the RIC and the different nodes, interfaces towards the SMO and so on. These are, of course, the mobile front hole interface, the mobile mid-hole interface, which have to be addressed and which bring new competences for the respective engineers. Good. Another point that has to be addressed while developing your competences is the extended range of vendors. Now, in particular, you will see with the emergence of Open RAN, there is a host of new software vendors on the market, which are emerging and trying to take a piece of the cake. This is normal, but it also means that we have an extended range of possibilities as to how our network will look in future. And this extended range of value and vendors and the extended range of, let's say, different software deployments will lead to a more, let's say, multi-vendor based radio access network. And this means that the knowledge that the engineer will have to have in terms of multi-vendor capabilities will increase quite drastically. There's also other aspects that we're going to touch on in the next slides. So yeah, let's jump right into it and have a quick comparison between the classical and the Open RAN deployment and the competences that are required. Now, when we talk about classical RAN, the one thing that I think all of you will agree is typically this is a single vendor hardware software RAN. Of course, one network operator is going to have different vendors, but within the radio access network solution that they are choosing, there's vendor A and there's vendor B. The network elements might be talking to each other, but the baseband unit and the radio unit in 99% of the cases are coming from the same vendor. And the hardware and software are from one and the same vendor. Now, what does that imply? That also implies that we have a basically guaranteed RAN integration. So if you have a baseband unit from vendor A and a radio unit from vendor A and the software from vendor A on both of them, basically it's guaranteed when you deploy it that it's going to work, that they are going to talk to each other. On Open RAN, it should also work, of course, and there is the Telecom Infra project is basically working strongly on different use cases and to work out the different scenarios. But because of the, let's say, huge amount of the different deployment options that we have, I would say it's not guaranteed that the RAN integration works without bigger problems. And we're talking now about the RAN specific nodes only. In addition to that, in the classical RAN, you usually have to talk about the core network integration. And maybe for those of you who have done that in the past, and for those of you who have done that in the beginning, let's say very beginning of LTE, or maybe even before the 2G, 3G, you might agree with me that while the 3GPP is specifying how a core network integration should be done based on the 3GPP parameters, we have learned that if I have a RAN vendor A and a core network vendor B, then what usually happens is the first integration tasks are pretty tough, especially when a new technology is emerging, because every vendor is implementing certain specifications in their particular ways. And this means that it's not always guaranteed if you set the same parameters on the RAN and on the core network that the network elements will actually talk to each other. And a lot of troubleshooting can be required. And yeah, so this is one of the typical tasks that we have and one of the typical competence development areas that are also required, for example, now in Open RAN. Moving onwards, there's also the NMC integration. These days, I would say this is pretty much plug and play with every single vendor every single incumbent vendor that you find on the market. You might have to configure an IP address and some security settings, but since again, many of those interfaces are proprietary, it implies that the NMC integration goes almost automatically or fully automatically. Now, when we take a look at Open RAN instead, you're going to see that there's, of course, the additional units which we have, or new units, such as the radio intelligence controller, such as the SMO. It's not totally new, but especially the system orchestration for RAN, especially when we talk about Cloud RAN, is something that is pretty new to all engineers. In addition to that, we do have the architecture of centralized unit and distributed unit. So let's have a quick look at the specific points that I've noted down here. First of all, hardware and software disaggregation. A challenging aspect in competence development is that currently, if you buy hardware from vendor A, you also buy the software from vendor A, you go to the training from vendor A, and you get it all in one package. Now, in an ideal case, in Open RAN, the hardware is common off the shelf, but that does not mean that you don't need competence development on it. Even if it's common off the shelf hardware, it just means that it's the basic platform which allows us to install our RAN software on top of it, or to deploy our RAN software on top of it. Still, hardware training might be required because different hardware vendors might have different features implemented. And the same applies for software training. So if I make a split between, let's say, CU and DU, and I buy different software solutions from vendor A and vendor B for CU and DU, then it basically implies that I have to go to vendor A and vendor B for training to learn how their specific implementation of the, let's say, general Open RAN software works. And this is a challenging aspect because basically it means I have to go to double the amount of training, or I have to find a way to get both of the training at the same time. Moving on, virtual infrastructure. As I mentioned, in mobile core networks, it's more common these days, or it's quite common these days. In mobile radio networks, not so much. If you take a look at the APAC market, you're going to find a lot of virtual infrastructure deployment for RAN already. If you would take a look on the EMEA market, I dare say that 80% of the EMEA market is still working on pure physical deployment. There are not so many networks which are using virtual deployment at this point. Of course, there is pilot projects and there's trials, but on a big scale, it's quite uncommon in the European, Middle East and African market to use virtual infrastructure. So definitely there will be a requirement for competence development in this area for the RAN engineers. Then front haul integration. The front haul integration is something that is pretty new. When we talk about front haul integration, the engineers have to understand how the integration is done, but they also have to understand what is a 7.1 split, what is a 7.2 split, and so on. These words or these terms are being used a lot, but if you ask a classical network engineer, okay, can you explain a 7.2 split to me? Most of them will say, I've never heard the term, or maybe I've heard the term, but I have no idea what you're talking about. Because for many of them, it's not that relevant right now until the Open RAN deployment actually, let's say, hits their market, until it's becoming more relevant in their respective network. Then one point that has to be addressed is the RIC and SMO integration. It's not really the integration, it's more the deployment work. But also when we talk about RIC integration, it's going to be interesting to see how vendor A, RIC, is going to cooperate with vendor B and vendor C, CU and DU. In an ideal world, everything works automatically, but once again, especially in the beginning, when you do your first integrations, you're going to figure that it's not always as simple as it seems. And the engineers will have to have the understanding, not only what is the RIC doing and what is it supposed to do, but also how are the DU, the CU, and the RIC talking to each other. Last but not least, we have the mid-haul and core network integration. While the core network integration is pretty much the same as you will find it in the classical RAN environment, there are still differences, because for a RAN engineer these days, at least when we talk about the physical RAN engineer, a deployment engineer, they're used to the fact that they take a LAN cable, they plug it in on one port, they plug it in on the other port, they configure some IP addresses, and it's going to talk to each other. The idea that we have a virtual IP network, that we have a virtualized IP communication, and that all the services which are currently, that all the hardware which is currently cable A to cable port A to cable port B will be a service or will be a application in future that has to be configured, is something that is quite challenging for many engineers to understand. Okay, so if you take a look at the classical training approach, usually almost every roadmap looks the same. So when you take a new engineer on radio access network, regardless of the technology that he's working in, he usually first of all gets the radio network introduction. This radio network introduction is either some training on the job by your colleagues, or it's by a third-party training company such as TFK Technologies and many others, who is being brought into the company to provide general radio access training towards your engineers. Or it's by the respective, let's say, network vendor, which is also taking care of the hardware which is being deployed in your network. So in general, the radio network introduction is more or less the same for everybody, and it's something that should stand quite at the beginning. I'm always a little bit surprised when I get engineers in my course which have been working in the market for 5, 6, 7 years, and they say, actually, that's my first training. I've no idea how it really works. I mean, I have a general idea, but I've never had any training on radio network technology as such. But it happens a lot. And on top of that, we are then splitting between, let's say, more the hardware-related courses and the planning-related, parameter-related courses. The hardware courses are typically courses which belong to the network vendors and are delivered by the network vendors. Of course, different network vendors are utilizing third-party training partners to, let's say, fulfill the training requirements, but in most cases, they are sold by the network vendor. And this is going to be, as I mentioned before, a very interesting approach in future, because the more different network vendors you have in your RAN, the more complex your training can get for your radio access network. And the question is really, do you have to go to vendor A, B, C, and D to, let's say, get trained on your entire RAN environment? Or is it going to be a task of third-party companies to, let's say, provide multi-vendor training? Theoretically, this is possible. Practically, however, you're going to see that any training company which is, let's say, an authorized partner for a specific network vendor, you are going to find that they are signing contracts, NDAs, etc., which prohibit them from providing multi-vendor knowledge. So this is something that can be quite challenging. First of all, for the vendor themselves, because the network vendor can teach in usual cases only their own hardware and software. And it's going to be challenging for third-party training companies, which might have the multi-vendor capabilities, but currently might not have the permission to teach on a multi-vendor basis. In parallel to this, if we talk about theoretical content, we're going to talk about the air interface training in most cases. So going deeper into the radio network technology, so that later on you are going to be able to do network planning, network optimization, parameterization, and stuff like this. The different training roadmaps that we have then are usually on the hardware. There's deployment training, there's a operation and maintenance training, integration training, and one training which is kind of more from the planning department, but strongly related to hardware, which is transmission planning. Because here, basically, it depends on the vendor capabilities. While transmission planning is an IP training class and IP networking class, it depends on the vendor capabilities, it depends on the hardware capabilities, how the transmission planning is actually done. On the air interface classes, we then find different parameter classes, which can be partly delivered by third-party companies, but at the same time, every network vendor, every software vendor is using the standard parameters, but with their own naming. So it is still quite vendor specific, because if you take a look at all the incumbent network vendors, it doesn't matter if you take a look at Ericsson, at Nokia, at Huawei, at Samsung, you name them, they all have their own specific naming for their parameters. So that means that most of the parameters, unless they are very feature specific, you're going to find within all the different software solutions, within all the different hardware solutions, but they all have their own names and you have to be able to map them properly. Then we have the different performance measurements and KPIs, which you have to be trained on. And also here we have, again, the aspect that different vendors, while they have the same performance measurement data, are naming the measurements in different ways. And the other thing that we are encountering is the KPIs. While we have similar KPIs, depending on the vendor that you are working with, you're going to see that they're calculated in different ways. And one and the same KPI might have different meanings. So again, something that is to be considered when we talk about Open RAN and a multi-vendor environment, these points have to be addressed to make sure that you are comparing the right aspects with each other, the right KPIs with each other, to make sure, as we say, not to compare apples and pears. And last but not least, there's of course radio planning, which has to be addressed. On top of that, so let's call it, this is the basic aspect of any type of radio training that we usually go through. Of course, different job roles will get different types of training. So it's quite untypical that everybody runs through all these different aspects of training. On top of this, especially on top of the hardware training and the O&M training, there can be, of course, NMC courses such as network supervision, remote supervision, such as configuration management, such as performance optimization with different tools. This is something that is very often done by third-party companies, but with the tools of the respective network vendor, or even with third-party tools. So there's plenty of performance optimization tools out on the market that could be considered. And of course, different planning tools on which you have to be, and which the specific planning engineers will have to be trained. Now, it doesn't matter whether we talk classical training or training for Open RAN, these aspects will still be relevant also in Open RAN. But the point is, with Open RAN, there's going to be additional aspects which are not being taught right now in any 2G, 3G, 4G, 5G courses that you typically can attend. And those aspects are, of course, the Open RAN specific aspects, such as Open RAN architecture. What is a RIC? What is a O1, O2, O3, whatever the different A interfaces? What is a front haul? What is a mid haul interface? Though this type of information typically is not found in a generic 5G, 2G, 3G, 4G technology training. The other part is the Open RAN deployment options. I think it was Marcin who already touched on that quite well. We have so many different possibilities to split our nodes. Is it going to be a fully integrated node as we have it now in LTE? Or do we have a CU-DU split? Or do we have a control plane, user plane split even within the CU and the DU? And all those different deployment options should be known to an Open RAN engineer. And then, of course, there's also the question of integration of Open RAN, which is, as we saw, different to the integration in a classical RAN environment. Operation and configuration of the Open RAN is also going to be playing a big topic. Then the part which is new or almost totally new within RAN is the cloud environment. And here we have to talk about training on virtual infrastructure. We will have to talk about virtual networking. As I mentioned, the cable which the engineer is pulling today from A to B is going to be a service in future. It's going to be a piece of software, which in the ideal case is automatically created, but probably has to be configured in some way. And the profile of the deployment engineers will strongly change. There will be, of course, still engineers which do hardware deployment, but the engineer who in future is going to do the VNF deployment or also the CNF deployment, this is something that is pretty new to the RAN environment. Together with this, as I mentioned already, we have the orchestration. Sorry that I didn't note down CNF. Of course, we talk about VNF and CNF here. And a part that will be very interesting for RAN is the dimensioning of the cloud environment. How to make it properly scalable. How to make sure that our data center provides the necessary capacity for our network. And on top of that, as I mentioned before, there's several other things that have to be addressed, such as hardware, common off-the-shelf hardware, still might require training. Software, in terms of software capabilities. If I have a multi-vendor environment, the weakest link is always the vendor that does not support a certain feature. And if I talk about the radio access network, which has a CU and a DU, and I have a software supplier for a CU, which does not support a specific feature, then it doesn't help me that the DU supports the feature. So we have to talk about the end-to-end capabilities of those software suppliers, and we have to talk about the end-to-end capabilities within our network in terms of usage and availabilities of features. And last but not least, there is the different interfaces, as we already addressed: mobile front haul, mobile mid haul, mobile back haul, and the planning and dimensioning for those interfaces. Because depending on the interface that we talk to, the planning and the dimensioning can be quite different to the typical, let's say, mobile backhaul planning that we have today on the market already. Okay, just a second. So the typical competence development track, as I see it emerging in different, let's say, incumbent network vendors, is always looking more or less the same. There's some kind of basic training where we talk about introduction to the technology. Then what happens quite a bit now is operating system training. A lot of the existing network engineers do not really have much, or let's say, have a quite limited knowledge in terms of operating systems, in terms of, let's say, different Linux distributions and so on, because it was not required. It was required to know the one specific software that is from one specific software vendor. It was not necessary to know Linux commands in many cases. It was not necessary in many cases to know how to configure an IP address on Red Hat deployment and so on. Then one thing that is going to be required is, in the basic training, is introduction to IP networking. Now everybody has an IP network at home, or mostly everybody has these days. So everybody knows more or less what an IP address is. But IP networking in the virtual environment is something that definitely is addressed in the basic training. Then certain cloud native competences have to be addressed. The different terms that we have. What is a what is a VNF, what is a CNF, what is a LUN, stuff like this has to be addressed and has to be known to the engineers. And as I mentioned, in RAN, it's quite untypical because it's not used that much. Different security concepts will have to be addressed, especially when we talk about interworking between different vendors, firewalling, secure connections, SSL, SSH, TLS certificates, all that stuff is partly already known and partly already used, of course, in the existing environment. But in most cases, the engineers are simply using what they get, and they are just implementing the ready certificates in the specific software they are using, but they don't have to deal with the problems that can come with different security concepts. And last but not least, in the basic training, we usually also find the legal requirements. And by legal requirements, I mean stuff like climbing courses for people who deploy hardware on a mast. I'm talking about courses related to power management, so that you are actually allowed to do the power cabling of a hardware. I'm talking about data protection requirements of specific country. So in Europe, basically the GDPR and the specific country implementations of this GDPR within Europe, but also worldwide. Data protection is playing a bigger and bigger role. On top of that, we have the Open RAN concepts, which have to be trained. And then on top of that, which I've already addressed, task-specific training. So if you take a look at the typical network vendor, they are offering integration training, operation and maintenance training, radio network planning training, testing and verification training, troubleshooting training. One thing that will be quite new is training on RIC. So let's say XApp and RApp software development training, or how to use the RIC, how to provide input to your XApps and RApps as a, let's say, planning engineer, how to set the frame parameters for those XApps and RApps. We say any AI is only as intelligent as the data which we provide to the AI. So this is going to be something that is going to be quite interesting as well. Now, as I said, this is more the standard approach, and with most incumbent vendors, you're going to find this approach emerging over the next, or let's say since the last several months or maybe last year, and you're going to find it over the next years to come. Third-party companies such as TFK are taking usually more of a customized approach. And at TFK, we basically split this customized approach into 6 different aspects, where the first aspect is the describe aspect. And this is more the work for the network vendor, where we ask, okay, what is your network going to look like? What do you want to look it like? Because as we said, we have so many different deployment options that the competence development track that you should take is strongly dependent on how you deploy your network and what you plan to do in future. Then the second aspect is the identification of team capabilities. So what knowledge is already, or which knowledge is already existing within the company, and which deltas do we have to actually get to the point that we can deploy Open RAN and that we successfully can operate an Open RAN environment. Then define, we are supporting our customers in, let's say, defining the future responsibilities of their teams, because some of the team responsibilities are going to change. The typical deployment engineer will not deploy any native hardware anymore. He will deploy, or she will deploy common off-the-shelf hardware. And then on top of this, we're going to deploy vendor A, B, C, D, E, F, G software solutions. Then there's the phase of the training design, where we talk about the type of training. Is it going to be a classroom training? Is it going to be a training on the job? Is it going to be a self-paced learning, which is on some learning management system? We're going to talk about training outline. So which type of content are we going to teach? What specific courses for which type of engineer, for which type of participant? And we are, of course, also defining the training duration, not only how many days is the training, but also how many days until the engineer should be fully capable of doing their job properly. Then there's the content creation phase, in which we develop customized content fitting to the requirements that have been identified before, and in which we also develop certification plans, such as certification questions, basic requirements for certification, and a full roadmap to say, okay, we have some kind of assurance that our engineers are capable of doing the job. And last but not least, of course, the training delivery, may it be instructor-led training, self-paced learning, video learning, training on the job, and so on. Now, earlier there was a question, where can I currently get additional information? Where can I currently learn about Open Run? And Marcin gave an answer by saying, currently, most probably you will have to work with the specifications. You will most likely have to take a look at the Open Run Alliance. You have to take a look at the 3GPP and learn from there. And I partly agree with him. Right now, since Open Run is emerging on the training market, you're going to see that a lot of the questions you are asking are only answered within the specifications. On the other hand, there are training companies and also suppliers existing which already have training roadmaps out. And I want to give a shout out here to Parallel Wireless, because I've seen some of the stuff that they put on YouTube, some of the general, let's say, introduction training into Open Run, which is very good material and definitely worth looking at as well. So it is worth to actually go on YouTube and just Google for Open Run. You're going to find some quite interesting information there, which is not only interesting, but also valid information provided by different players on the market who really know what they're talking about. So it's definitely worth checking that out at the current stage. If you are taking a look at, let's say, getting generic training, you mentioned, unfortunately, I don't remember who asked the question, but to the person, I remember you are working within Ericsson. I know that within Ericsson, for example, you can find quite a bit of generic information, general information, sorry, about Open Run as well. And you will find the same also within other incumbent vendors, such as Nokia, such as Huawei. All of them have their own roadmaps existing, although many of them, let's say, are still in the phase of implementing the different training solutions. And of course, there is plenty of training companies on the market, may it be TFK Technologies for customized solution, or any of our valued competitors and colleagues on the training market, which also have their solutions and are rolling out their respective training. Now, as to some key takeaways that I hope are interesting for you from this session. The RAN market right now is still very much this RAN engineer-driven market. If we take a look at Open Run, more and more IT competences are going to be required within the RAN environment. And this is something that definitely needs to be built. It happened, as I mentioned, maybe 5 to 10 years ago, and it's still happening today within core networks. More and more of the engineers are learning about cloud environment there, and it will be required definitely also on the radio market. Then we have a new architecture, so there will be new competencies required. May it be competencies to work on the RIC, may it be competencies to develop X apps, may it be competencies to develop R apps, may it be the interface planning, which I've addressed before. But anytime you have a new network architecture, there are new competencies which have to be learned. At the same time, it implies that our telco job profiles will change. We are not going to be looking at the classical engineer who has done that for the last 25 years and knows 2G, 3G, 4G, 5G. The telco market will look more and more on engineers which have IT knowledge, which have virtualization knowledge, which have knowledge on data centers and stuff like this. This is something that is more and more emerging and definitely will be a key to success in future. Together with this, the competences of the teams within a radio access network will change. Then I've touched on the point that multi-vendor knowledge is something that will be required more and more in future. It's already required today because a typical network operator has more than one vendor in their network. But with the diversity that we get with Open RAN, or the possible diversity that we can get with Open RAN, multi-vendor knowledge will be key to operating Open RAN successfully. And last but not least, customization can be key. Why can it be key? Because as I mentioned, most of the software suppliers, software vendors, hardware vendors that we find are teaching only their specific solution. And the times in which a radio engineer went for 6 weeks of training before he was able to do his job are basically over. When I started my career 17 years ago, I went through a training project of maybe 8 weeks, and then they said, okay, now you are a radio trainer for, back then it was Siemens hardware. After 8 weeks, if I tell my customers today, okay, look, first we have to go through 8 weeks of training and then your radio engineers are ready, none of my customers is going to be pleased with that. They say, okay, I give you 5 days. And that means you will not have the time to run to 4 different vendors and get training from 4 different vendors. You will most probably look at one vendor who can supply all of that. But that also puts me to my open questions. And the first open question I have, and this is something that has to be considered by the Open RAN community, by the different network vendors, but also by the different training companies out there. And the question is licensing. Licensing for training materials, licensing for hardware, licensing for software, and the, let's say, possibility to deliver multi-vendor training when you are an authorized training partner for a specific vendor or for several vendors. Because as I said, at the moment, this market is very restrictive when it comes to multi-operator training. You will find a lot, multi-vendor training. You will find a lot of multi-vendor training offers out there, but the question is always, are those also, let's say, authorized training partners for the specific vendors, or is it more based on, let's say, on the job experience, and then I've worked on 3 different vendors, so now I become a multi-vendor trainer. So the question is going to be, who is going to be delivering training in future? Is it going to be the network and the software vendors who do that? Or is it going to be a task of specific training companies which do that? Are there going to be any type of cooperations between the vendors to be able to deliver such a training in a multi-vendor environment? And last but not least, a question is, how will the ecosystem evolve? And what I mean in particular is, if you take a look at the good training today, in particular, when we talk about operation and maintenance, integration training and stuff like this, usually it implies that we have some hands-on experience on the solution which is actually being deployed within the network of the specific operator. And this is something that can be very challenging when we talk multi-operator. Because if you take a look at most of the training centers that you find worldwide, and it doesn't really matter who owns them, they are all specific to the vendor that owns them. Of course, there's several multi-vendor training centers existing, and of course there are the TIP labs existing, but we have to consider what we're talking about here. A large-scale Open RAN deployment will mean thousands of engineers that want to have training. And with the existing environment that we have in terms of multi-vendor capable training centers, I am a little bit worried that a lot of the training will have to run on the, let's say, test environments at the operator. And usually the test environment at the operator is not necessarily designed to run proper training exercises. Okay, I hope that the ideas that I gave today are interesting to you. I would like to thank the organizers of this training one more time, of this webinar one more time, to give me the chance to talk here. And I'll quickly switch back to the first slide one more time. because, of course, we have a quick question and answer session after my contribution here. But in case you feel like contacting with me in future, or if you have any specific questions that you do not feel like asking right here, you can always contact me under clemens.zibuschka@tfk-technologies.de. And I'll be happy to answer your questions and get back to you with my experience and with my input. Thanks a lot.
Yeah, thank you very much again, Mr. Zibuschka, for the very interesting presentation. And now we will open the last Q&A session for about 10 minutes before we close today's event. Is there anyone who would like to ask their question directly? Please do raise your hand and unmute yourself.
Yeah, I have a question, Gaurang, this side.
Yes, please.
Yeah, so as you said that there will be much modifications and update regarding to ORAN in the technology. So I have a question, Clemens, that will there be any usage of Python programming, Python scripting as well, along with machine learning and all those things in ORAN?
Most probably there will be. The point is that, you know, when we talk about machine learning, when we talk about AI and automation, what you usually have is you, of course, have the different applications which are, let's say, taking care of the changes that have to be made to the network. But nevertheless, the XApps and the RApps, they have to be maintained, they have to be deployed, they have to be provided with the let's say frame parameters under which they are working. And there's definitely use cases in which Python scripting can be interested to provide this input, for example.
Okay,
I hope I understood your question correctly. But
yeah, you give the right answer. Thank you so much, Clemens.
You're welcome.
Yeah, thank you very much also for the question, Mr. Gaurang. Is there any other question?
Yes, Govind this side. I have a question that
Yes,
for radio engineers, is there any standard certification related to the ORAN that if the radio engineer wants to upgrade themselves, then would you recommend any certification kind of standard certification?
I want to be fully honest with you. I'm still kind of looking for a vendor independent standard certification myself, which I've not really found until this point. There is standard certification roadmaps existing, but they are always a little bit vendor specific. And so I know that there is a certification roadmap existing within most of the incumbent vendors. I think when you look at some of the more emerging vendors, as I mentioned, possibly Parallel Wireless, possibly also Fujitsu, yeah, you might find something there, but I've not found, let's say, a general, I've not found a general certification by a big nameable company that is not touching on their specific implementation. Unfortunately.
Okay. Okay, then we'll have to wait.
Yeah, but I have to admit as well that, you know, given the fact that we are an existing training supplier for several of the incumbent network vendors, we are, of course, let's say, closely related to them and taking a look at their training roadmaps and so on. I might as well be wrong. So there's a good chance that there's a company out there that I'm not aware of that has such a program that is really, let's say, touching on it, on the topic in a general way and not with their specific implementations. So there might be something out there that I'm not aware of yet.
Okay, thanks for that.
So we'll now open for one last question. Before we close today's session, is there anyone who would like ask their question directly?
Hello.
Hello.
Yes, I have one question. Actually, what I realized, actually, thank you for your very good sharing for in this webinar. What I realized here is there are a lot of development competence that we need to enhance in here, especially for fresh graduate or for radio optimizer. So I mean, like, which one we should prioritize first? Is there any suggestion from you?
When it comes to the fresh graduate, I think that taking a classical approach, so going through the technology, then via the Open Run training and then towards the specific tasks actually makes sense. When we talk about engineers who already have experience, I think you mentioned the optimizers in this case. When we talk about radio optimization, the radio network itself does not really change. So the prioritization in that case, I would say, is mostly on learning which impact the RAN intelligence controller will have onto our optimization work. Which parts are going to be optimized in future? How are they going to be optimized? And the other aspect that I think is necessary to understand is, so how is my work affected by the fact that I have AI, which is also doing network optimization? I think this is the main approach that should be taken, because the classical network planning as such, to a big extent, will still be valid, because let's say the general frame will still be set, at least for the time being, by our optimization and planning engineers. In future, the more data there is available, the more probable it is that this will be taken over also by AI to some extent, and we will in future then most probably set the frame parameters for this optimized planning and optimization. Yeah.
Okay, thank you.
Yeah, thank you very much.
If I may add one thing, just because regarding the previous questions about general certification roadmaps, what might be a surprise is that I did not say, okay, look, you can come to us to TFK and we're going to have a general certification roadmap for you. If it comes as a surprise, TFK currently is focusing mostly, as I mentioned, on the customized approach. However, like most of the vendors, we are of course also putting out our, let's say, general approach towards the Open Run certifications. But our, let's say, training portfolio is not ready for this. It's something that will be emerging over the next several months. Okay, thanks.
Yeah, thank you very much for the wonderful sharing session, Mr. Jibuchka. Now we have come to the end of today's webinar. Before I close the event, I would like to ask our audience and also our speaker, if possible, to turn on their video to take a photo to commemorate today's event. So I'll give you guys a few minutes to prepare yourself and turn on your videos. Okay, everyone's ready for the first page. Okay, 1, 2, 3. Again. 1, 2, 3. For the second page. 1, 2, 3. On the third page. Okay, 1, 2, 3. And lastly, 1, 2, 3. Yep. Let me come back to the first page. Okay. Thank you very much, everyone. Now we have come to the very last event of the Run webinar series. Again, I would like to express our gratitude to our guest speakers, Mr. Diansky, Mr. Mazur, and also Mr. Jibuchka, and our partners, especially Telkom University and Telkom Intra Project, supporters, and event organizers who made today's webinar possible. During our last 5 webinars, we have always joined by extraordinary speakers and practitioners from the telco world. We from TechPros would like to thank TIP and Telkom University again for the opportunity for TechPros to contribute to the world of Open RAN Indonesia. We'll see you at the next Open RAN Indonesia event. I'm Fanny Udris, your moderator for today, signing out, and we'll see you at future events. Have a great and hopefully sunny weekend, everyone. Take care and stay healthy. Goodbye. Thank you very much.
Thank you very much.
Bye. Thank you, Fanny.
Thank you very much.
Thank you.
Bye-bye.
Thank you. Thank you.
Thank you.
Thank you very much.
Thank you very much.
Thank you very much. Thank you. Thank you. Thank you very much.